Welcome to class. I did promise to prove a circle theorem, a circle geometry theorem that is so important that if you know it, 80% of your struggles in this topic will be over. So the theorem says that the angle that an arc of a circle sustains at the center of the circle is 2 times that which is sustained at any point on the circumference. The angle is sustained here is 2 times that which is sustained at the center. Now, it has a circle theorems have particular proof pattern. So what we do first is to write out what we are given, state what we are given, and we are given circle PQR having center O. This theorem holds true for both situations. So whatever I say here works for that also. Now is to state what we're asked to prove. And we are asked to prove that angle POQ, the angle at the center, is 2 times angle PRQ, the angle at the circumference. But the next thing we need to do is to construct, if there's any need for construction. So we write construction. Here we will join OR and project to N. So we say join OR, project to N. So I join this, project it to N, and in this case, same project to N. Now, next thing we do is proof. We state the proof. Now, the first thing we notice is OR is equal to OQ and is equal to OP. The reason is that they are all radii of the circle. Same thing obtains over there. Now, having seen that, we can call this angle here x1 and call this one x2, x1 and call this one x2. Now, what do we notice? We notice that x1 is equal to x2 because they are base angles of triangle POR. Base angle of POR. So we state the reason: base angles of triangle POR. Similarly, we can call this angle here y1 and call this one y2. So we see again that y1 is equal to y2. The reason is that both of them are base angles of isosceles triangle QOR. Now, the angle at the center is POQ. And it is clear that that POQ is made of 2 angles, PON and QON. This and that. This and this. Now, PON is equal to x1 plus x2. This angle here, PON, is equal to this plus this. The reason is that There's a theorem that says that the exterior angle of a triangle is equal to the sum of the opposite interior angles. For triangle PON is exterior to it and is the sum of the opposite interior angles of that triangle. So we state the reason. This is exterior angle of triangle POR. Now, PON, don't forget we have said x1 is equal to x2. We stated that here. So I can write this as x1 plus x1. So this will give me 2x1. Same here. This is equal to the sum of that. Now, the other side of it, QON, the other side of POQ, QON is y1 plus y2. For the same reason, it is the exterior angle of isosceles triangle QOR. Now, just like in the other case, QON will be y1 plus y1 because we have said y1 is equal to y2. So this will be 2y2. Now, we go back to this equation that the angle PON, we've seen it to be 2x1. Plus QON, we've seen it to be 2y1. So 2x1, 2y1. 2x1, 2y1. Now, so POQ, when we factorize these two is common, we have x1 plus y1. Now, looking at the diagrams, x1 plus y1 make up the angle PRQ. x1 plus y1 makes the angle PRQ. So we can conveniently say that POQ is equal to 2. These two make up PRQ. So finally, we can say that POQ, the angle is equal to 2PRQ. And that's what we set out to prove from the beginning. Now that you have understood this, please like, share, and follow so we could have other proofs of circle theorems. Thank you.